Hi guys. So we're going to take this continuation of the day 3 notes you got earlier this week, which were like 20 minutes long. I'm definitely going to make this one shorter, but we're going to use the Pythagorean theorem today. We're going to build a rotational angle on the XY axis, create the reference angle, and draw the triangle to the x-axis to create the right triangle again. But we're going to use one more property to get our trig ratios on this one, and that is the property of a circle. And sometimes they ask these questions. I'm going to do 2 examples of one including a circle for you, and I'm going to ask you to do 2 on your own. And there is no Delta Math assignment for this one. I'm just going to have you post a picture of your 2 problems that you did on the next page on your own into the assignment on Google Classroom so I can give you a credit for completion on that. So do your best with this. It's definitely putting together a lot of skills. So it takes a lot to get each one of these problems done. But here's where we're going to add one property of a circle. So this is the only new thing you're going to get today. Everything else we've already learned. The important circle property we are using is about the radius. I put a circle on the notes page here. But an important property of a circle is this. A circle has a center point, right? And any line that goes from the center to a point on the circle is called a radius, or little r. I could draw a radius there. I could draw one here. I could draw one here. I could draw one anywhere. And the key concept that we're talking about the radius here is that if I say that this radius is 10, this one is also 10, and this one is also 10. It really doesn't matter. I could draw any radius I want anywhere from the center to a point on the circle, and it's going to be of length 10. In our problems that we're doing coming up, we're going to use that property of the radius of a circle to get one side of our right triangle. Okay, let me show you how that works. In this problem, they're saying a circle is centered at the origin with radius 10. So we're going to use this radius of 10 units part. Okay, radius of 10 units. So let's just quickly sketch a circle of radius 10 units. So there's my grid, and I'm going to try to get a decent circle here. Nice and big, so we have room to get all we want in there. Now, looking at what I have, from the origin to this point on the x-axis, that's a radius. This is a radius. From the center to that side is a radius, and from the center to the top. Those are all radiuses, but I could draw any arbitrary lines in here and get more radiuses if I needed them, okay? But let's see what the problem is asking us for. So the next thing says, it says the terminal side of an angle theta intercepts the circle in quadrant 2. So that's another key point that we need. This is quadrant 1, this is 2, this is 3, and this is 4. So we're going to draw our terminal ray from the origin anywhere we want, usually up the middle, in quadrant 2. Okay? Now, we have our terminal side. Our terminal side creates a reference angle with the x-axis that we call theta, and that's where our theta is located there. Now, we have from the origin to here, this is a point on the circle, and we can drop a line directly straight down to the x-axis, and that makes a right angle. Magically, we have created the right triangle that we need here. So there's our right triangle. Okay, so we're going to be able to use the Pythagorean theorem because it's a right triangle, and we can get our trig functions from this right triangle. Okay, the other clue that they gave us in this problem is that the y-coordinate of point C is 8. So this 8 is the y value. Okay, so first thing I'm going to do is go over here, and I'm going to label this as point C. And this C, I do not know what the x value is, so I'm just going to call it x. But the y coordinate is 8. So this has a coordinate of x and 8. All right, now the 8 is the y value. Y's go up and down. My up and down side of my triangle is this leg right here, and I'm going to give that a value of 8. And because I'm going from the x-axis up to point C, that's a positive 8. Okay? So I have one side of the triangle there. Now, I need one more side to use the Pythagorean theorem, and this is where the circle comes into place. Okay? So the circle radius, right, here's the origin, And here is a line directly from the origin, which is the center of my circle, to a point on the circle. This right here is a radius, okay? All the radiuses of this circle are 10 units. So the radius is 10. That gives me that side, right? So the next thing I need to do is find this third side of the triangle, because I have the 8 and I have the 10. I need to find this third side. Now, that travels in the x direction, so I'm just going to go ahead and call it x there. And I'm going to have to use the Pythagorean theorem to solve it. So let's find the hypotenuse. Across from the right angle is 10. 10 is the hypotenuse. I need to know which is the hypotenuse for the Pythagorean theorem. My legs are 8 and x. So using the Pythagorean theorem, it's a squared plus b squared equals c squared. Excuse me. Okay, the legs are 8 and x. So this would be 8 squared plus x squared equals, and the hypotenuse is 10. So that would be 10 squared. 8 squared is 64. 10 squared is 100. Minus the 64. And I get x squared equals 36. So to undo the x squared, I take the square root. If I take the square root of that side, I take the square root of the other. The square root of 36 is a 6. Okay? So my x side here is 6. All right? But if I was plotting this point 6, I'm moving to the left on the x-axis, so that is a negative 6. Okay? So we got a negative number to deal with here. The next thing we need to do, the problem asks us, is we need to find the cosine of angle theta. So to find the trig function of any angle, I use SOHCAHTOA, S-O-H, ka, to, a. I need the cosine, so I'm using the C, and that would be A over H. And let's label the rest of this. So looking at my reference angle theta here, opposite my reference angle goes across, my O side is there. My A for adjacent is next to our reference angle and the right angle, that's my adjacent. So cosine requires A and H. A is negative 6 and H is 10. So the cosine of our angle is negative 6 over 10. Oops, sorry. Now, negative 6 over 10 simplifies. A number that goes into both 6 and 10 is 2. So I can divide 2 out of both the numerator and the denominator. Negative 6 divided by 2 is negative 3, and 10 divided by 2 is 5. So the cosine of our reference angle is negative 3 over 5. I want to make one other point while we're here on this problem. There is a shortcut, to know if you're getting the negative or positive right, and this is the shortcut. These are the quadrants on our grid. There's an old saying, A, S, T, C. All students take calculus. Okay? ASTC. Now, ASTC gives us just a shortcut to know if it's positive or negative in each quadrant. This is how it works. All are positive in this. So sine is positive, cosine's positive, tangent's positive, cosecant, secant, and cotangent are all positive. So all the trig functions are positive in this quadrant 1, okay? In quadrant 2, the letter is S. S is for sine, okay? So sine is positive. And then sine and cosecant are reciprocals, so they're going to be positive here. If you're not sine and you're not cosecant, you are negative in quadrant 2. So in our example over here, this was a cosine and it's negative. Cosine would be negative in quadrant 2, and so would tangent and cotangent, okay? Let's follow this thought. So all of them are positive here, just sine and cosecant are positive in quadrant 2. If you have your terminal side in quadrant 3, this is the letter T. So T stands for tangent. A tangent angle would be positive here, and its reciprocal, which is cotangent, would be positive here. All the other trig functions would be negative here. So sine is negative here, and cosine, and their reciprocal functions cosecant and secant would be negative in quadrant 3. When we get to quadrant 4, calculus, right, C stands for cosine, right? And cosine is reciprocal with secant. Cosine is positive in this quadrant, and secant is positive in this quadrant. All the other trig functions are negative in that quadrant. So how we can just double check that we have our signs right? All the trig functions are positive in quadrant 1. Just sine and cosecant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. And cosine and secant are positive in quadrant 4. So we're just talking about the positives. Everything else would be negative, okay? So that's a cute little thing to know about. Let's do this last example. We have a circle centered at the origin and has a radius of 16. Let's go ahead and sketch that. A circle with a center at the origin, and my radius is 18. I'm going to write that down because I'm going to need to know that. All right. The next piece of information, it says the terminal side of an angle theta intercepts the circle in quadrant 3 at point C. So I'm going to draw that terminal side. Draw any old ray out here, and it intersects the circle in quadrant 3 at point C. Okay? All right. Quadrants are 1, 2, 3, and 4. The y-coordinate of point C is negative 12. So here we go again. So C, we don't know the x value, but the y-coordinate is negative 12. And what else did they give me? What is the value of tangent? So we're going to need to get a triangle and figure that out. So I'm going to make my triangle with the x-axis. From the point, I'm going to go straight up to the x-axis and draw my right angle. My reference angle goes between my terminal ray and the x-axis, and now I have that triangle that I have been wanting. Okay, there's my triangle. Okay, it told me that the radius is 18. That's any radius. The radius is a point from the center to a point on the circle. My radius in this triangle goes from the center to the point on the circle, so I know that this is 18. Okay, I need one more point or one more side length on my triangle here. I'm going to look to my values here. I don't have anything for the x value. The x value would go from the origin left here in this direction. Okay, I don't have a value for that, but I do have a value for the y, and it says y is negative 12. So here to here is y, up and down is y. That value there is going to be negative 12. That makes sense because from the x-axis I went down, and when y is negative, I go down. The other value that I need in this is from here to here, which is the x value. I'm just going to call that x right there. Okay? I am expecting my x value to be negative. I'm going to need to make it negative if it doesn't come out negative, because I go left in x, that would be a negative movement for x. So I have two sides. The Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Let's use that to get the missing side. So legs are x and negative 12, so it'd be x squared plus negative 12 squared equals the hypotenuse squared. The hypotenuse is 18. I know it's the hypotenuse. There's the right angle. I go across from the right angle and get the hypotenuse. This is x squared plus 144 equals 18 squared is, they said 16 here. Let me just adjust that. 16, and I'm going to have to change it on my picture. It's 16. Sorry about that. So 16 squared is 256. All right, now I need to subtract the 144. X squared equals 256 minus 144. I get 112. Okay, square root this side, square root that side. X equals the square root of 112. So far, so good. let's look at the 112. I'm going to factor the 112. 112, and I do menu, factor in my calculator. I get 2 to the 4th times 7. Okay? Now, I can break up, I need powers of 2 to take it out of the radical, so I'm going to break up my 2 to the 4th to 2 squared times 2 squared. 2 plus 2 is 4, so I'm done. And then times the 7. This one can come out, and this one can come out. So that comes out as just a plain 2. That comes out as a plain 2. 2 times 2 equals 4. So this 4 comes outside the radical. The 7 is going to stay in because it didn't simplify. So the side length, x, is 4 rad 7. That's what I was looking for to begin with. So right here is my x. Now, this is a negative in the x direction, so it's going to be a negative 4 rad 7 for that side. All right, the last thing we need to do on this one is find the tangent of theta. So, using SOHCAHTOA, so, ka, to, a. We need tangent, so we're going to use the T for tangent, and I need O over A. So let me go ahead and label my triangle. Looking from my reference angle, going opposite, this is my O. Next to my reference angle is my A. And across from the right angle is my hypotenuse. All right, so cosine or tangent is O over A. So it'd be tangent theta equals side O is negative 12 and A is negative 4 over 7 or negative 4 rad 7. I have a negative divided by a negative. That's going to be positive. And then 12 and 4 goes into both of those. 12 divided by 4 is 3, and 4 divided by 4 is 1. So this would be positive 3 over rad 7. I still can't leave my answer in that form because I have a radical in my denominator. I will have to multiply it out. So to multiply the top by the radical and multiply the bottom by the radical, the top becomes 3 rad 7, and the bottom, rad 7 times rad 7, you're left with just the guts. That's plain old 7. So the answer to this is tan theta equals 3 rad 7 over 7, and that completes this. So on the next page, you have 2 of these to try on your own. They're pretty complex. I will post the answers to these so that you can have a hint working through them. And then you're going to post a picture of this completed page with your work on it on Google Classroom Assignment, and then I'll give you credit for it in School Tool. Contact me if you have any questions. The best way to reach me is on my email. I'll talk to you soon. Bye-bye.